All right, welcome back. So, you've done the hard part. You've trained this incredible, powerful AI model. But now what? Today, we're going to take that brilliant model out of the lab and plug it directly into the real world. We're building a lightning-fast, production-ready API. Let's get into it.
This is the fundamental question, right? An AI model just sitting on your computer is pure potential. To turn that potential into a real product, a real service, you need a bridge, a way for any application anywhere in the world to talk to your AI. And that bridge, my friends, is an API.
Okay, so here's our game plan. First, we'll talk about the big picture, why APIs are so essential for AI. Then, we'll introduce our secret weapon, Fast API. And then we're getting hands-on. We're going to build a server, learn how to handle data, and finally, structure our code like a true professional.
Think of it like this. Your AI has the brains, but the API, the application programming interface, is the voice. It's the universal language that makes that intelligence accessible to everyone. It's the standard, accepted way for all kinds of different software to communicate, whether it's a mobile app, a website, or even another server.
And just to be clear, we're not building some old-school API from the 90s. We are building an AI-powered API. So instead of just fetching data from a database with some simple, boring rules, our API is actually going to have a brain. It's going to use our AI models to understand what's being asked, make smart decisions, and generate intelligent responses. It's a total game changer.
Now, take a look at this. This really shows you the two main ways AI apps are being built today. On one hand, you've got your traditional web apps that call on AI services behind the scenes. And on the other, you've got new platforms like custom GPTs. But here's the key, the big takeaway. What's at the heart of both of them? APIs. They are the engine driving the entire modern AI ecosystem. It's that simple.
So if we're going to build this AI-powered bridge, we need the right tools, the right materials. And for modern Python developers, that material is, without a doubt, Fast API. It's a framework that was literally designed for this exact job. So why is everybody so excited about it? Well, it comes down to three main things. First, it absolutely lives up to its name. It is ridiculously fast, mostly because its core is built in a super performant language called Rust. Second, it's laser-focused. It does one thing, building APIs, and it does it incredibly well. And third, and this one's a lifesaver, it saves you a ton of time by automatically generating interactive documentation for your API as you build it.
All right, enough talk. It's time to build something. We're going to start with a super simple Hello World API, just so you can see for yourself how easy it is to get a live server up and running with Fast API. And honestly, it all boils down to these four little steps. You import the library, you create an app instance, you tell that app which URL path to listen for, and then you just write the simple Python function that runs when a request comes in. That's it. You're done.
Okay, so you've written the code. Now what? You run this one single command in your terminal. Uvicorn is the high-speed server that actually runs your code. Main.app just tells it, hey, look in the file called main.py for an object named app. And that magical little -reload flag? It tells the server to automatically restart anytime you save a change in your code. It's fantastic for development.
Now, this is the really crucial point. We write the server code one time, but that single server can now talk to pretty much anyone. A user can hit the URL in their web browser, a fellow developer can use a command line tool to test it, another program written in any language can call it automatically. This is the power of building an API.
So our server is up and running. That's great. But how do clients actually send information to it? I mean, your AI model is going to need some inputs, right? So let's look at all the different ways your new API can receive data.
Okay, think of this slide as your ultimate cheat sheet for API inputs. Data can be baked right into the URL path itself, like a user ID. It can be a query parameter, the stuff after the question mark, perfect for search terms or filters. For more complex stuff, you'll use the request body, almost always as JSON. And finally, you have headers, which are great for sending metadata, like an API key.
And here is another feature that developers absolutely love about Fast API. Just by using standard Python type hints in your code, telling it a variable should be a string or an integer, Fast API automatically validates all the data that comes in. So if you say a user ID has to be a number and someone sends text, Fast API automatically rejects it with a perfectly clear error message. This saves you literally hours of writing boring validation code.
Okay, so a single file is great for a Hello World app. But for a real-world application, you need a much better structure. And this brings us to a professional design pattern called layered architecture.
The core idea here is actually really simple. Don't just dump all your code into one big messy file. We separate our code into logical layers. We'll have one layer that's only responsible for handling web requests. Another layer will have the core business logic, the part that calls our AI model. And maybe a third layer is responsible for talking to a database. The point is, each layer has one job, and it does that one job really, really well.
I absolutely love this analogy for explaining it. So think of it like this. You are the client. You make a request. I need a new laptop. You make that request to the web layer. Let's call her your mother. Now, she's the main interface, but she doesn't do everything herself. She passes that request to the model layer, your father. He's got the core logic. He knows where the resources are. Once the task is done, the response comes all the way back through your mother, back to you.
So why bother with all this? What's the point? It's all about making your application robust and future-proof. When you separate things like this, you can test each layer all by itself. Better yet, you could completely swap out your database, go from Postgres to MongoDB or whatever, and the web layer doesn't even have to know anything changed. Your code stays clean, manageable, and it's built to last. This quote from the source material just sums it up perfectly. When you build in layers, you're not building a fragile house of cards. You're building a flexible, resilient system where different parts can be upgraded or totally replaced without bringing the whole thing crashing down. Honestly, it's the key to building professional, scalable applications.
So look at that. We've gone all the way from a standalone model to a fully architected, globally accessible service. The tools are right here, and they're more powerful and easier to use than they have ever been before. So really, the only question left is, what amazing AI-powered service are you going to build?